In this video, we're talking about how to solve one-step equations. So let's first talk about what is the goal of solving an equation. The goal to solving an equation is to get the variable by itself. So you want to get the letter all by itself. Now, in order to do this, we need to perform the inverse operation. So just like the properties that we talked about with the inverse of addition and the inverse of multiplication, we're going to need to use those. So the inverse of addition is subtraction. The inverse of subtraction is addition. The inverse of multiplication is division. And the inverse of division is multiplication. Okay, so let's look at some examples about how to solve equations. And just like order of operations, these are going to seem really easy to some of you at first. But we are getting you ready for Algebra 1, and you need to know how to do the inverse operation, so you need to show it to us. Because as problems start to get more complicated as you go up into upper level math, you're not just going to be able to look at a problem and say, oh, well, how do I solve this one? Oh, I just think the answer is this. You need to know exactly what you're doing in order to be able to solve the problem. So we're going to be looking for you to show your work. So if we look at problem number 1, I find it most easy if we draw a line down the equal sign to kind of split the problem into two. And remember that this is a calculator unit, so you may use your calculator for any of these solving problems. So if we look at this one, I have b plus 14. I'm going to circle my letter, and you're going to leave your letter alone. But what is stuck with the letter that I need to move it away? So just like when we were drawing the pictures with the bars, and I had to draw, if I had a problem like this, and I needed to get the bar by itself, I had to do the opposite, which would have been open boxes, and then I would draw more open boxes over here, and then these would cancel. I'm doing the same thing in these problems, but instead I'm using the math. So if I look at this one, this is b plus 14. Well, I need to get this plus 14 away. The inverse of plus 14 is minus 14. That's that additive inverse property. Now, if I subtract 14 from one side, I also need to subtract 14 from the other side. Draw the line so I can do a little bit of math. I didn't have anything to line up with the b, so I'm just going to bring it down like I would if I were doing a division problem, but I'm not doing a division problem. I'm just carrying it down because I haven't used it. This is going to cancel because I have positive 14 to negative 14, which really becomes 0, so I don't need it. It's canceled. And then if I do 27 minus 14, I'm going to get 13. So I don't have anything left with b. b is all by itself, so I have b equals 13. Now, how do I check this to make sure that it's right? Well, let's rewrite the problem, but in this place of b, I want you to leave a blank. So blank plus 14 should equal 27. Well, what should go in the blank that was b? 13 is going to go in the blank. Is 13 plus 14 27? Yes, it is equal to 27, so it's balanced on both sides. So I added those together and I got 27, and then I just carried down this 27 here, so 27 is equal to 27. It's a balanced scale. It's a balanced equation, so it is correct. Now, what would have happened if I wouldn't have gotten it right? So say, what if I got 12 and I plugged 12 in here? Now I don't want you to write this, I just want you to watch. 12 plus 14 would give me 26. Is 26 equal to 27? It's not. 26 and 27 are not the same number. So that would have meant that I did something wrong. If I got 12 over here, I made a mistake. So in all reality, for this unit and for this test that you're going to take on equations, you shouldn't really get any of these problems wrong, because you can plug in your answer that you get, do the math, and see if you got it right. So you shouldn't get any of these wrong. If we look at number 2, start by drawing your line through your equal sign. Find your variable. What is stuck on the same side of the line with your variable that you need to remove? In this case, I have this -4. Well, how do I get rid of, or -4, however you want to read it, how do I get rid of this 4? What's the inverse, or what's the opposite? Well, the inverse of this is going to be +4 to both sides. Draw a line across the middle to do some math. I'm going to start at this side. 5 plus 4 is 9. Equal sign on the line. Bring down the W. I haven't used it. -4 plus 4, or -4 plus 4. If I don't have 4 and then I get 4, I end up with 0, so they cancel, so I can cross them out. There's nothing left for me to bring down, so I just have 9 equals W. Well, let's check our work. If you want to, you can put the 5 here. If you don't want to, you don't have to. I'm going to put blank -4, and it should equal 5. Well, the blank is 9. 9 minus 4 should equal 5, and it does. So if you want to, you can put the 5 here to keep the problem intact. You solved this, and then the 5 just came down. 5 equals 5? Yes, it does. So you got it right. Let's look at another example. In this here, draw your line down the equal sign. Find your letter. Remove the number on the same side as the letter. Now, if you didn't notice about the one we did previously, it was a little bit backwards. But as long as you find your letter and you deal with the stuff that's on the same side of the letter, you won't get it wrong. So if we look at number 3, the 7's on the same side of the letter. Now I need to figure out, how do I get it away from the letter? Well, how are the 7 and the S connected with what operation? They're connected with multiplication. The opposite or inverse of multiplication is division. Now, I do not want you to use a little division symbol. We're not in elementary school anymore. We know that fractions are division, so I want you to draw the fraction bar and put a 7 underneath. Same thing on the other side. Draw a line across the middle, so let's do some math. Now, I'm not touching the S, but I am dealing with the 7's. 7 divided by 7 would just be 1, and I'm going to bring down the S. 56 divided by 7 is 8. Now, look at this problem. Do I really need to write the 1 in front of the S? Or do I just know that if I just write the S that it's a 1? Well, I don't really have to write the 1 there. It's just an S. Because in reality, there is one S that shows up. So the answer to this is S equals 8. Now, if you notice, I'm circling my answers. Your answer is not the check step. Your answer is, what does the letter equal? That is the answer. So in this case, we're saying that S is equal to 8. So let's come here and let's check our work. So we have 7 times S, I'll put a times there, equals 56. 7 times, well, what did we say S was? 8. Going to do a little order of operations here. 7 times 8 is 56. Going to bring this guy down. Does 56 equal 56? Is it balanced? Yes, it is. So that means you got it right. All right, let's look at number 4. Now, number 4 is a little bit tricky, but it's not bad. Find your letter. Find your variable. There's my variable. It's the R. Now, I have this 6 on the same side as my variable. How are the variable, the R, and the 6 connected? Well, there's a bar between them. What does the bar mean? A bar tells you that it is division. We know that division is represented by a bar. You could also think a fraction looks very similar to a division symbol. So this is a fraction. I'm dividing. Now, the inverse of division is multiplication. That's that multiplicative inverse property. So I'm going to multiply by 6 on both sides to cancel this here. So when I have 1/6, because really there's a 1 up here with the r, times 6, and it would be like 6 over 1. You think of it as 1/6 times 6 over 1. You would multiply across and you get 6 over 6, which would just equal 1. So in reality, this would just equal 1, but I don't need to write the 1 because we talked about it over here. I don't need this, so I'm just going to bring down the r because I did all that work to cancel it to get it to go away. And then 3 times 6 is going to be 18. So my answer, I'm saying, is r is equal to 18. But I want to make sure that's right because I should never get a problem wrong on my test. So I'm going to say blank divided by 6 should equal 3. Well, r is 18 divided by 6 should equal 3. 18 divided by 6 is 3. Bring down the 3 here. Is 3 equal to 3? Yes, I got it right. Remember, if you don't get them to be equal, you need to come back over into your problem and check your work. Okay, now these ones get a little bit more interesting because they are true fractions times letters. And it's not that much different. And we've been dealing with fractions, so it's no big deal. Draw your line down your equal sign, find your variable. Now, in this case, I have 1/2 times c. Because they're smushed together, that means multiply. But that means I'm going to have to divide. But think about it with our fraction rules. Are we ever allowed to divide fractions? And the answer is no. We cannot divide fractions. We need to do keep, switch, flip. So we're going to keep this fraction the same. We're going to switch to multiply, and we're going to flip it over. So it's going to be times 2 over 1. And then we have to do the same thing over here, times 2 over 1. Draw a line. Let's do some math. If you need to rewrite this, rewrite it for yourself so that you can see it's 2 over 1 times 1 over 2. See? Because really this becomes 2 over 2, which would just simplify down to 1. So I don't need it. I'm going to carry down the c though, because really there's 1c here. And then I'm going to do this multiplication here. I'm going to go across the top, across the bottom. Lonely whole numbers go over 1. 12 times 2 is 24 over 1. And that just simplifies down to be 24. So right now I have c equals 24. And if I do the check step, I have 1/2 times something equals 12. Well, the something is 24. Lonely whole numbers go over 1. And if I do this multiplication here, 1 times 24 is 24. 2 times 1 is 2. And if I divide this, I get 12 is equal to 12. So I got it right in this problem. Same thing for number 6. Draw your line down your equal sign. Find your variable. In this case, it's the w. If I look to see what's stuck with it on the same side, I have 2/3 times w. So how am I going to get away the 2/3 if it's being multiplied by w? Well, I need to do my keep, switch, flip because I'm not allowed to divide fractions. So I'm going to multiply, keep this one the same, switch to multiply, and then flip it over. So it's going to become 3 over 2. And I have to do the same thing on this side, times 3 over 2. And if you need to line it up a little bit better, you can line it up here, if that makes a little bit more sense to you. Line it up as best you can, or you can always rewrite the problem if you need more work. Or, I'm sorry, more space. So this one here would be 2 times 3 is 6, 3 times 2 is 6, and 6 over 6 would just equal 1. So this is all going to cancel here. And I'm just left with w, because it would be 1w. And then this one here, lonely whole numbers go over 1. 6 times 3 will give you 18. 2 times 1 is 2. And then I could finish this out. 18 divided by 2 is 9. So 9 equals W for this. So this is my answer, 9 equals W, but let's check it. So I have 6 equals 2/3 times W, which is 9. Lonely whole numbers go over 1. 2 times 9 is 18. 3 times 1 is 3. 18 divided by 3 is 6. And then I'm going to bring down this, and 6 is equal to 6. So I did get it right.